Hello, Mr. B here again. I'm going to talk to you a little bit about the crystals that you're going to be making for Project 3. Yay, crystals. We're going to be using something called Epsom salt. Epsom salt. By the way, whenever you see the word salt, you know that it's an ionic substance. So it's something that has an ionic bond in it. Okay, ionic bonds are dissolved really easily in a substance that we are very familiar with, and that is water. Okay, ionic bonds are charged, as you know. There's a positive and a negative ion, and they're attracted to each other. And for reasons that are too complicated for me to explain, water molecules also have a charge on them. So there's a positive and a negative side of a water molecule. And that helps to dissolve this ionic bond. Okay, so whenever you see that something is a salt, you can be confident that it can be dissolved in water. Okay, so for these crystals, we're going to be using a principle known as supersaturation. Okay, so we have our water. Here's our cup of water, and we're going to heat it up. Okay, and when all the water molecules get heated up, what do they start to do? They start moving around. Okay, this is the movement. It's not very good movement. They're moving around a lot, and that movement helps them to dissolve a lot of salt. You can put a lot of extra Epsom salt in here, and that's going to help it dissolve more Epsom salt than if it wasn't hot. Okay, so we're going to dump, here's our big cup full of Epsom salt. We're going to dump a bunch of it in there, and it's going to dissolve a ton of it in the water, and we're going to put so much Epsom salt there's even going to be a little bit of extra on the bottom. Okay, because there's going to be so much that it's not even going to be able to dissolve all of it. Okay, but then we know that there is the maximum possible salt dissolved into this water. Okay, then we're going to take this water and we're going to cool it down really fast. Why would this change anything if we cool it down really fast? Well, because the water is hot, we can say that the salt is supersaturated in the water. That means that there's more dissolved in there than we would normally be able to have under normal temperatures. Okay, so if we take this really, really salty water, this water that has all sorts of Epsom salt in it, and we put it in a refrigerator. Here's me drawing a refrigerator for you. Got the little freezer compartment up there, the little handle. We put it in there, then this water starts to cool down really fast, okay? And when the water cools down, the molecules don't move as much. Try to get rid of some of this movement here. And if they're not moving as much, then not as much salt can be dissolved in them. Okay, so now all of a sudden you have all this extra salt, just like it doesn't know where to go, it doesn't know what to do. So the salt molecules, they're kind of looking for buddies. They're looking to form what kind of bonds? Ionic bonds. They start looking for other ionic bonds to form. And one of the properties of solids that we learned when we learned about solids, liquids, and gases is that solids like to form repeating patterns. Okay, and this is especially true with ionic solids. Okay, so as the water is cooling down really fast, the salt is looking for buddies to hang out with, and eventually it starts forming a very repeating pattern. Repeats over and over and over again, like this, and it's going to keep growing and growing and growing and growing as the water cools down quickly, and eventually you're going to get a crystal. So that is what's going on with the crystals and why Epsom salt can help us make them.